Scientists are back on the hunt for gravitational waves. The famous LIGO Observatory, which studies space and mind-bending gravitational waves, is teaming up with two other gravitational wave observatories, the Virgo interferometer in Italy and the Kamioka gravitational wave detector in Japan. Together, these four observatories will allow us to unravel the secrets of colliding black holes and neutron stars. I'm talking mind-blowing discoveries that could reshape our understanding of the universe. Here's what gravitational wave scientists are hoping to find in its latest search. First up, we have the heaviest black hole, the largest black hole we've ever detected through gravitational waves from the merging of two smaller black holes, weighed in at a staggering 142 times the mass of the Sun. With these new advancements, scientists are pushing the boundaries, aiming to find the presence of colossal black holes around 1,000 times the mass of the Sun. Now, nothing can escape a black hole, which makes them a little difficult to find and pinpoint, even when they literally wobble all of space and time. But what if we spot black holes swirling in a cloud of gas? That swirliness would kick up the gas surrounding the black holes and set off a cosmic firework display. Detecting the radiation from these swirly, gassy black hole collisions will help us pinpoint exactly where they are. In doing so, we could gain unprecedented insight into the precise locations and dynamic nature of these celestial crashes, unveiling new information about these extreme cosmic collisions. But that's not all. The precise localization of these gravitational wave events could give us an independent way to measure the expansion of the universe. Here's another one. Did you know that the origin of precious metals like gold and platinum are linked to the collision of neutron stars? In 2017, scientists witnessed the gravitational waves from one of these events, shedding light on the origin of these precious metals. Pun intended. By discovering more of these collisions, we can further unveil the mystery of the creation of gold and platinum in our universe. This next one really surprised me. When massive stars reach the end of their lives, they go through a cataclysmic explosion known as a supernova. But right before the supernova happens, the core of the star gets crushed under the weight of the rest of the star. And apparently that colossal crushing creates gravitational waves. When I think about it, it makes sense because any accelerating mass generates gravitational waves. When I wave my hand like this, I'm generating gravitational waves. Albeit they're really weak, but still gravitational waves. So when a great mass like the core of a massive star suddenly collapses, yeah, of course it's going to create gravitational waves. Detecting gravitational waves from such a core collapse will grant us unprecedented access to the inner layers of dying stars, revealing a front row seat to their final moment. Now, we can't talk about gravitational waves without mentioning Einstein's general theory of relativity, one of the cornerstones of our understanding of the universe. However, we still lack a complete unified understanding of gravity and the quantum world. Here's why black holes step in. By studying them, we can test the boundaries of both strong gravity and the quantum world to bridge the gap between these two fundamental theories that explain the inner workings of our universe. And last but not least, literally anything else, like the unknown unknowns. Who knows what's out there for us to discover? The ones that I'm most excited about are the supernova ones, because I didn't even know that was a thing until now, and the unknown unknowns, because literally, again, who knows? Who knows what's out there? So brace yourselves, because who knows what's in store in this next search for gravitational waves. In the meantime, did you know black holes convert? Find out more in this video.